What we have here is a rectangle, a pentagon, and a hexagon. And what I want to do is establish why this property exists for the number of angles in any n-gon. So n being the number of sides, 4-gon, 5-gon, 6-gon, of course they have a quadrilateral, pentagon, whatever. But if it's like a 12, or let's say 14-sided figure, 14-gon, after 12 they don't have special names. What it tells us is the sum of the angles in any polygon is the number of triangles in the polygon minus 180. And what I'm inferring here is that the number of triangles in any polygon is two less than the number of sides. Let's take a look. This is a rectangle. If I draw on this diagonal, I'm looking at two triangles, right? This has 4 sides and 2 triangles. Looking at this pentagon, I draw on these 2 diagonals 1, 2, 3 triangles. So this is 5 sides. We get 3 triangles. We're looking at a 6-sided polygon, a hexagon, drawing some diagonals. Triangle, 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 triangle. We get 4 triangles. There's a limit to how far I want to go to make a point. I don't want to draw a 7-sided figure. Those are hard. So 4 sides minus 2 is 2 triangles. 5 sides minus 2, 3 triangles. 6 sides minus 2, 4 triangles. In general, any number of sides minus 2 equals how many triangles exist. How many degrees in a triangle? 180. So 180 plus 180 is 360. 180 plus 180 plus 180 is 540. 180 plus 180 plus 180 plus 180 is 720. Easier than adding 180 a bunch of times. Number of triangles times 180 is how many degrees within a figure. So if it has 7 sides, you'll be multiplying 5 times 180. 900. 8 sides, 6 times 180, 1080, and so on. All right. So just like that, if you know how many sides there are, you can immediately tell me how many degrees within that figure by that rule. Another property here has to do with what's called exterior angles. Okay. This is a very easy formula, easy property. If you draw all the exterior angles in a polygon, it doesn't matter how many sides. This one has 5 sides. It could be 20 sides. It doesn't matter. But if you draw all the exterior angles, so to the same side. So this side extended this way, next side extended. What I'm saying is don't go like that way on this one. So all of them the same direction. So this is to the right, above, left, like that. So you're going around and every angle's being hit. I'm not doing something weird like extending this line both ways and getting that angle too. Okay? So we're going in the same direction on every one. The sum of those angles is always 360. Okay? I didn't do anything special to draw this pentagon. I drew a line and a line and a line. I just made 5 straight lines, connected them so they connected. Made a pentagon. If I pull these 5 angles up, let's see, it helps to have the right tool for it. If I pull these 5 angles out, there's angle A, there's angle B. Nicely. There we go. Angle C, we'll bring that in, like so. Bring in angle D. And there, nice. There, okay. Then finally angle E. Boom. That's it. All 5 angles together create a circle, right? A circle has how many degrees? 360. All right? So, sum of all the angles, exterior angles of a polygon is 360. It's not 360 times the number of sides. If there's 5,000 sides, the answer is 360. If it says exterior angles, the answer is 360. There will be a test this year. Okay, I'm making bold predictions here. There will be a test this year with this exact question on it. It'll say, what is the sum of the exterior angles in a 20-gon? I don't even know what gon it will be. It will be something gon. The answer will be 360.
Do like a 6 million gon.
It might be a 6 million gon. The answer is 360. Okay? The answer to that question will be 360. The study guide you get will have that question on it. The answer will be 360. When I do the video for the study guide, I'll tell you the answer is 360. I'm telling you today the answer is 360. And somebody in this classroom is going to do 360 times the number of sides. It always happens. Don't be that person. Don't be that person this year. There's always a person that does it. They feel terrible because they lost 7 points on the test for something so simple. But it always happens. Don't be that person. All right. So, looking at a picture, knowing the properties, establishing properties, what's going to be helpful to me in this problem? Okay, what I'm looking at is a hexagon, 1, 2, 3, 4, 5, 6 sides. So immediately, there's 4 times 180, so 720 degrees is how many degrees all the angles inside the hexagon is. Since I'm only establishing one angle inside there, that's probably not going to be helpful, but it's knowledge, it's something we know. It doesn't hurt to know that. Okay, another property I see happening here, this happens a lot. These two angles make a straight line, right? Property for that straight line is 180. So I know that y plus x plus 55 has to equal 180 degrees for sure. Can I solve that?
No.
No, because too many letters. But it's a true fact. I can write it down. If I end up finding out what x or y equals, then I have enough information then to solve that one, right? So we'll put this one on the back burner. It's true, but not necessarily helpful yet. Next property. Exterior angle 1, 2, 3, 4, 5, and 6. We have all the exterior angles identified as either specific numbers or algebraic expressions, right? Those 6 angles have to add up to 360. So I know that x plus 55, that angle, plus 80, plus 40, plus 50, plus 65, those 4 angles, plus x, the last angle, has to be 360 degrees, because that's what the property says. Again, properties are used to take a look at a picture and be able to create an algebraic equation from that picture. Like terms, x plus x is 2x. All these things add up to something. 120, 210, 290. Is that right? I'm doubting myself. 120, 290. Yep, 290. Just add up all like terms. All the numbers add up to a number. All the x's add up to x's. 2x plus 290 is equal to 360. Move the 290 over. So 2x equals 70. Therefore, x equals 35. It says find x and y. Just found x. And wants to know what x equals. Now this green equation that we put on the back burner can be solved because we can figure out what y equals. So y plus 35 plus 55 is equal to 180. Go ahead, Maddie. Won't hurt anyone. So this x changed to 35 because that's what x equals. This equation becomes y plus 90 is equal to 180. So therefore y equals 90. Doesn't y look like a right angle?
Yeah.
But you can't assume that.
You cannot assume right angles. Very good. So even though it looks like a right angle, we're not allowed to assume that. Typically on your standardized test, it's going to say figures are not drawn to scale. Okay, that just telling you if it looks like something, don't assume it. You have to know some algebraic property that allows you to say that to be true. So x equals 35, y equals 90 in the case of that one.